Good morning and welcome to the beautiful Eiffel stage here at ChangeNOW. Our session this morning is dedicated to exploring space, how we use and how we must protect space to protect our lives, our environment and our livelihoods here on Earth. Now, Earth observation has been helping us understand and mitigate climate change for some time now, but orbital space is becoming crowded with satellites, and the risk of operating is increasing because of space debris. Over the next hour and so, we're going to be learning about how we can protect Earth from space, but also how learnings from Earth here can help us protect the space above us. Now, before I introduce our first speaker, let's get warmed up on the subject and find out a little bit about you. How many of you are working in the space industry here? Okay, probably about 10 or 12 in the room. Great, welcome. How many of you all feel that you have a good idea about what the space sector is doing to help us mitigate climate change? Ooh, a few less hands, maybe only 5 or 6 there. Well, our first guest is well placed to help us better understand the work being done in the sector and also some of the ethical questions that the sector is asking itself, for example, about its carbon footprint. We've asked her to share some examples of work being done on climate change as part of the Space for Climate Observatory. So please welcome Laurence Monnoyer-Smith, Head of Sustainable Development at the CNES, which is France's national space agency. Laurence, welcome.
Good morning, everyone. We are entering a new space era. Before space, old space, it was this. You'll recognize a picture taken in 1969. Now, today, we're here with new space. Kind of science fiction by SpaceX, just like a movie. But also, new space, that's this. Thousands of satellites around the Earth. It's also this. Creation of military forces pretty much everywhere in the world. So with the new space industry is developing at a very fast pace all over the world. From 6 in 1966 to more than 80 countries owning satellites in orbit. Now, 61 countries have a space agency. That means that we create a space agency pretty much every year. Space is everywhere in your life. When you get up in the morning and you look at the weather forecast on your mobile phone, you use space. You're in the street and you receive a WhatsApp from your son asking for money. Sounds familiar, isn't it? You use space. And then you wire money to him. And you know that during the transaction, it will be recorded by some atomic clock on one of the Galileo satellites. You use space. In the evening, you go to dinner to some friends. And you use the global navigation satellite system to go quicker. You use satellites again. And there you discuss with your friends and you learn that one of your friends is lost at sea during the Route de Rome. But fortunately, he was spotted and he will be rescued thanks to the COSPAS-SARSAT system. So basically, our life have become dependent on satellite equipment, whether for telecom, for defense, for navigation, or for climate change. Hence, the explosion of the new space system, with the production upstream, with the production of nanosat, infrastructure, IoT, Internet of Things, equipment, logistics, etc. And downstream, so here on the picture, you can see all the new, this is pretty much the French new space. Downstream, with the production of many new services in the field of environment, water management, or even methane or carbon monitoring. We're thus seeing an explosion of public investment and private investment in the space sector. from $36.3 billion in 2000 to $170 billion in 2023. With the big players that you can see in the slide, of course, the US, China, Japan, France, and Russia. And an exponential growth in the number of launches carried out in the past 10 years. This picture is quite impressive here. Down the picture on my pointer is not working quite well, but you can see this, the explosion of the number of launches. We will reach 2,600 launches in 2023, compared to 10 years ago, 240. Of course, this transition to mass launches brings with it numerous consequences, benefits and risks for the Earth, and that's what I'm going to talk about now. I'm going to start with the benefits because before serving to make kittens video available, the space industry was first and foremost serving science. Understanding the universe, the sun with solar orbiter, you can see this great photo on the slide. Understanding the solar system, Jupiter with JUICE, or Mercury with Bepi Colombo, and very recently the James Webb Telescope. I'm sure some of you recognize the fantastic photo given by the James Webb Telescope. And James Webb gave us the chemical composition of exoplanet atmospheres. He gave us also the first infrared rays of the universe. Science has long been the essential reasons for launches, for rocket launches. But satellites not only have been watching the universe, they also have been watching the Earth. And this since the 1960s for weather forecasting, but also from the second half of the 1980s, as you can see in this slide, to highlight the hole in the ozone layer with the NASA Nimbus program. This is where when the United Nations Convention on Climate Change was created following the Rio conference, the scientists all over the world mobilized all the emerging remote sensing tools to measure various factors of the system Earth that you can see on these slides. So system Earth is characterized by a growing number of factors, just to monitor the whole climate change. And scientists create this network to understand network, which is called the Climate Earth Observation System, and the Global Climate Observation System satellite. And this is, what you have on this slide, is what is called the essential climate variables. 55 of them help the scientists to monitor the climate change and to modelize it. On this 55 climate change variable, 55, they are, more than half of them, 60% of them, can only be documented from space. Along these essential measurements is also what we call altimetry. And here you have Topex-Poséidon, that is one of the first satellites sent by the US, by NASA and CNES, 1992 by Ariane, making the first measurements of height from space, and especially the heights of oceans. And since then, the scientists have been able to highlight not only the level of the rising water levels, but also its very uneven distribution. As you can see on the slide at the bottom, where it's red, you have a very quickly increasing level, and other areas of the world where it's not increasing as much. And also, they make us understand the respective contribution of melting ice on glaciers and the rise in temperature to understand the elevation of the water levels. Quite quickly, satellite resources were also devoted to emergency rescue. And here you have the presentation of the International Space and Major Disasters Charter that has been created 20 years ago. And it provides real-time information for civil security. This charter has been activated since its creation in 20 years ago, 869 times. Last time it was last week in Mozambique and in Mongolia. And climate change provokes, of course, an increasing number of major disasters. Just a quick word about Copernicus also. The unique Earth observation system, the European Earth observation system that has been launched in 1998 and operational in 2014 to better coordinate the data that were dispersed between different projects and entities and sciences. The European Commission spent more than 7 billion euros in making this, to establish this network of Earth observation satellites. And these satellites, as you can see on this slide, this is the Copernicus Climate Change Service, one of the Copernicus services that is offered to the world. And you can see there the various information that the Climate Change Service is giving us. The temperature, surface temperature, of course, but also monitoring carbon dioxide. On the bottom right here, you have the concentration of nitrogen in space during, before COVID and during lockdown. You can see in real time the importance of the reduction of activities in the concentration of nitrogen in space. Just a quick word about the Space for Climate Observatory, which is also an international alliance created in 2019 by President Macron. During the One Planet Summit. And here, in this international alliance, you have more than 47 agencies and international organizations such as UNDP and UNEP, United Environment Programme. And they develop together operational projects just to help territories to adapt to climate change. Nowadays, we have more than 71 projects all over the world, which are developed with end users just to answer to specific problems they have for adaptation. And they're working in these projects are basically focused on the protection of biodiversity, forest fire protection, but also deforestation, tropical deforestation, and in real time. The SCO digital toolbox offered data, free data, that are coming from, that I developed through the projects, and they offered free through platforms, through Data-Terra, also infrastructure. And now you can find all those algorithmic bricks also freely on the Geo Data Hub. Among a flagship project, we can find Stockwater, this very important, very interesting project which measures in real time the water stocks available in the dams everywhere in the world, live. Also, Litosat Bretagne. Litosat is a platform that offers to the local administration live data about coastal submersion, as you can see here. However, the increase of these activities raises crucial questions about their sustainability, whether in space or in orbit. Space is in fact the only industrial activity whose effect extends beyond the troposphere into the stratosphere. And one of the most worrying issues is one of space debris. In the last 2 years, there has been an enormous increase of the number of commercial satellites launched to near-Earth space, which means in low orbit. Many of these satellites are being launched into large constellations in order to provide communication services around the globe. There are nearly 6,500 operational satellites in orbit alone, and more than 9,000 in total, including the inactive ones. But apart from these satellites, we also have objects as you can see on this slide, in the graph in the bottom of the slide, 900,000 objects over 1 centimeter, 34 objects over 10 centimeters. Scientists say today that we have reached the beginning of the Kessler effect. So what is the Kessler effect? The Kessler effect is a situation where orbital saturation produces its own waste through collision, increasing collision. So more collision produce more waste, which produce more collision, and so on and so forth. This is called the Kessler effect. We have counted 38 avoidance maneuvers from the International Space Station since 1999, and just last year, 4. So that's a symptom of the starting of the Kessler effect. Today, the community is mobilizing all over the world, albeit late, on the environmental footprint of space activities. It is clear that the most obvious, which is launches, is far from constituting the highest footprint. Emissions of particles in the upper layer of the atmosphere linked to the combustion of the propellant cause effects that are currently poorly understood. We don't really know what it does in the upper layer of the atmosphere compared to the pollution that can be done with the same combustion on the Earth. On the other hand, we have chemical reaction that depletes the ozone layer. And this is, and always has been, the main concern regarding rockets' emissions. Other particles injected into the stratosphere absorb and reflect also solar energy. Then they modify the flow of radiation in the atmosphere, heating the stratosphere and cooling the surface. This is what we call the radiative forcing effect that has the effect of modifying the whole albedo of the Earth. And therefore, it's also modified the quantity of energy that is injected into the atmosphere, which also provoke thermal changes, which also contribute to the depletion of the ozone layer. And finally, we also have great uncertainties regarding the impact of the thermal erosion of metals during the atmosphere re-entry of objects, being launches of satellites. And the measurements of metal particles and their persistence remains to be done. So now we are working on this. Many research is being done about these various effects, radiative forcing and thermal erosion and metal erosion. Here, just maybe not to describe in detail these slides, this is just to show you that scientists have been working to try to do a life cycle assessment of various types of satellites. In blue, you can see what is linked to the launches, the rocket launches, and the propellant emissions. And you can see it's very variable from one constellation to a single satellite. And here, there are 2 slides, one with a linear scale and the other one with a logarithmic scale, just to show you the difference of CO2 footprint between various types of satellites. The telecom LEO in low Earth orbit and exploration or Earth observation, meaning that the thousands of satellites that are currently being sent on low orbit are actually very, very worrying in terms of CO2 emissions. And so in the long run, we really do have to think about what type of satellite we're launching, thinking about, we have to think about, do we really want to go to 6G and send thousands of satellites? So to finish, I'm just going to skip this one, but there are also lots of local impacts because of spaceport. We are currently building pretty much 1 spaceport a year. There are 27 on the globe, and with the rise of small sat, we're also building more spaceports, meaning more impact on the local biodiversity. To finish this talk, we have to think about what we want for our future. Of course, the space industry is essential, as I've tried to explain, essential for Earth observation, for science, for fighting against climate change. But today, space activities must, with citizens, ask itself essential questions about its future development. What do we want? Should we allow highly emitting space tourism to develop? Should we take our place in the race to mine Moon and Mars? Doesn't this race risk leading us to our own downfall and ultimately making space unusable? Should we instead focus on scientific research, scientific exploration, and climatology? I had the last one, sorry. Space is a common good, and as citizens, awareness of these issues is crucial. And for me, for everyone working in the space industry, citizens' expression in this subject is essential so we can prioritize what we want to do in the next 10 or 20 years. Thank you.
Laurence, thank you so much. Thank you for that detailed overview and the work that you're doing at the Space Climate Observatory. Now we're going to bring space right here on stage and welcome a collective of artists and activists who mobilize their bodies and the space around us. Please welcome Minuit 12. Bravo. Bravo, bravo, well done. Thank you so much to Minuit for that impressive use of space. They're an amazing group of creative artists and activists. Their name, Minuit. Make sure you follow them on Instagram to find out more. Now, I'd like to welcome our next guest to the stage so we can learn about how our planet is changing from space and the data that we're collecting and how it's being used. So please welcome Elisabeth Hamdouch, who's the Deputy Head of the Unit for Earth Observation and in charge of Copernicus at the EU Commission. Elisabeth, welcome. Fabulous. Thank you. That's a huge glass. Okay. Now, when I was preparing for this conversation with Elisabeth, I went to the Copernicus website, and I noticed that the tagline on the homepage says, Europe's eyes on Earth. And as I read on, I learned that there was a Earth observation satellite constellation. How many of you were aware of this, that we have, Europe has it? Okay, a few more people more informed than me. Yeah. So this is Copernicus. Elisabeth, can you tell us what Copernicus is and what it's doing for climate change?
Good morning, everyone. Copernicus is the Earth observation flagship of the European Union space program. So the European Union is actually very active in space. Maybe not everyone knows that. So we are not only bureaucrats in Brussels sitting on our desk and writing laws, but we are also active in space. And active in space in a way to really bring it to good use on Earth. And Copernicus is our own satellite constellation. So we own, as a European Union, this fleet of satellites that is considered to be the world's leading environmental monitoring program. And we implement it together with our partner, the European Space Agency. And what is it? So it's a constellation of satellites. They are called the Sentinels. That observe very important information on the state of our planet. So we also say we take the pulse of our planet. And we combine this with additional data that we get from other sources of space observation, be it commercial satellites or institutional satellites, as well as data that we collect on Earth, so-called in situ data, or from the air or from the oceans. And the beauty of the program is that it's not only about technology or research and the beautiful satellites in orbit, but that we transform these observations that we get into information services and information products that are easily accessible to everyone. So we have the data, the raw data that are interesting for scientists and with which you can do a lot of things if you know how to interpret and manipulate the data. And our information services, they give you very easily accessible information. And for this, we have thematic information services for environmental monitoring, about the land and vegetation, about our oceans, about climate change and the atmosphere. We have a service for emergency management and also for security applications. Shall I continue with a bit more on climate change?
Go ahead,
yes,
yeah, and then I'm gonna come in and throw some questions at you.
So for climate change, I've been asked to focus in particular on climate change because this is very much at the heart of the discussions here at the summit. It's actually, we say climate change, but what we are facing is a climate crisis. And we have an extreme urgency to act, and this is why climate change, and the Green Deal is very much at the heart of the European Union's policy priorities. And for Copernicus, we have therefore, developed this dedicated climate change service together with our partner, the ECMWF, which is the European Centre for Medium Range Weather Forecast. Thanks. And what does this climate change service do? First of all, it gives us the data that we need. So it monitors a lot of variables of what we can observe from space about the climate on Earth. So this is about the temperature, for example, of land surface and of water bodies, be it lakes or be it the oceans, but also water height, so to see how the water is rising. And a lot of other variables that either have an impact on climate change, like, for example, pollution, air pollution and other forms of pollution, and also that show how the effects of climate change are impacting our ecosystems. So, for example, the quality of the health of vegetation or of water. And it gives us the insights. So I mentioned already that it's a program that transforms data into information and understanding, intelligence. So we have advanced models, data analytics, working on high-performance computers, and also with artificial intelligence.
Can I ask you actually a little bit about this data? So you're taking the data, you're also bringing in data from other partners, you're turning that into information and,
yes.
and some of the projects and the work you've talked about. One of the things we like to do here at ChangeNOW is see how we can put people together and give them access to information. Is this data open source? Can people actually access and use it for their projects also?
Yes, so the data is openly available to everyone. You can just register on our website, copernicus.eu, and use the data directly. You can also access the Copernicus data space ecosystem,
okay,
where you can directly use the data on a cloud system. So you don't have to download the data, but you can manipulate them directly there on the system and even combine it with models and data analytics that you would like to use. And it also has the whole archive of the data. And then you can access our Copernicus thematic services that I mentioned before. So for example, for climate change, we have the climate data store, and we have all the information products on air quality or products focusing on specific sectors. Because one of the objectives is not only about understanding climate change, but it's also to help accelerate the change. And to accelerate the change, you have to give the data that is needed by all different kinds of actors, so that take important decisions, like, for example, mayors or municipalities. But it's also about change in sectors. So, for example, we have specific information products that could be used for the energy sector or for the water sector, for food and agriculture, transport, mobility, health, tourism.
Okay, I want to come and talk about some of those projects in just a second. I interrupted you. I'm going to interrupt again. So this data and information is available out there. How many people in the audience are already using it? Ooh. I can see one, I think I saw one or maybe two hands going up. Okay, so it's there, it's available, it's open source, and the archive, as you mentioned, also.
Yeah.
Okay, can you give us some of the concrete examples? I interrupted you, but can you continue telling us about some of the concrete examples where this data and the information then that you're transforming this into is having a significant impact? You mentioned water just earlier.
Yes, so there are many, many examples. I pointed already to some of them. Water is a very important example, and I would like to talk about it. On Friday, we had the World Water Day. Also being here in Paris and in France, I know that this is a country that is very much aware about the severe impact that people, the economy, the environment can have if you have water issues. If you have France even declared a water crisis, so the scarcity of water, droughts and floods can have a very severe impact. So what can Copernicus do to help with that? First of all, Copernicus helps us to understand the trends that we can observe, but also the interaction of different phenomena. So for example, it can assess how the rain and snowfall, or also the lack thereof, impacts the water supply that we see in rivers, lakes, the oceans, but also the soil moisture and the recharge of the groundwater. And in models, this can combine with other variables that tell us something about the state of the ecosystem. Because if we have a healthy, strong ecosystem with healthy vegetation and healthy soil, then a water stress can be absorbed much more easily. But if, for example, a country has a low water inflow, or a region has a low water inflow, and we observe already from the satellites that there is a soil erosion, a very dry soil, and maybe also coastal erosion, which can be very dangerous, combined with a bad state of the health of the vegetation, so very dry vegetation, then our system can issue drought warnings to the region. And if we have a drought and then we see a temperature rise and risks of heat waves, we also know that these heat waves in that region will be much more severe and will again have an impact of drying the region even more. And then we can also issue warnings on increased risks of wildfire, which will again have a more devastating effect. And then we also know that the region, once water comes back again, is much more exposed to risks of flooding. And also our Copernicus services can help how to manage the water. So in the hydro energy sector, for example, or in local water management, to use all these data to adapt the level of water in water reservoirs or dams, as we have seen it earlier on the slides. And the decision makers can use this service to do risk assessments, to use the warnings that we issue, and to help to be better prepared for it.
This is one of the things that I love about this conversation, but also ChangeNOW. This session is actually focused on space, but we can see the importance of space, in fact, in looking and taking care of everything that we're doing here on Earth, whether it's our water sources, the risk mitigation, as you mentioned, forest fires, but also in enabling us to better tune the systems, our water management, water preservation, and the climate, the temperatures. Do you have any other concrete examples you want to share with us really quickly? You mentioned water. Is there anything else that you're particularly proud of or pleased that you'd like to share with us here?
The energy sector is also a very good example where our data can help the sector to optimize the planning in terms of locations where the renewable energy will be most productive in terms of wind energy, in terms of solar energy, and also to operate it, so to see how, like for hydro energy, how the water flows can be adapted, and how solar energy can be really calibrated in a way to make to collect the most energy, and also for energy transmission. To use all our data on the climate projections to optimize the energy mix if we see that we have, for example, a colder or hotter weather and we have more wind or less wind, how the energy mix can be optimized.
So from what you've described, it's clear that partnerships are at the very heart of your Earth observation work. You're working with EU member states, with the European Space Agency, with meteorological and weather agencies out there. What other partnerships are you looking for to complement and to sort of augment this data and the information that you're using to observe Earth?
Yeah, so we have very strong partnerships. Also, as I mentioned before, it's like the world's leading environmental monitoring program. So in order to build this excellence, you can only do it when you build strong partnerships. So we have very strong institutional partnerships that you mentioned, and also at international level and at the research level, very strong partnerships. So what would we like to develop more? This is, first of all, commercial partnerships. We started already to change our way of doing business because, of course, if we implement such a large satellite system, there's also a lot of business behind. And recently, we have worked increasingly with new space companies in order to embrace like the potential that they have and use new solutions where we could act like an anchor customer for them to also help them grow and promote innovation with this. And we are also working with companies that use this data to develop a downstream market, so that go the extra mile between what we offer in terms of open data that is freely available to all of you and the end user. Because a lot of the end users, they need to have this bridge. So there is a very interesting market for companies who can build on our infrastructure, which is like a public service, freely available, and which offers continuity. So we are not a research project that offers for the next 5 years or for the next 10 years some data that you can play with. No, it's a long-term, stable infrastructure where companies can use the data, develop business models, and offer it to their clients. And for this, the ChangeNOW Summit is a great opportunity. So I saw very few hands only raising that you use the data, but I would hope that here it gives an opportunity that people who have a need, for example, a sector who would like to transform, a company that would like to transform, a mayor who says, I would like to change my city, comes together with people who have bright ideas, who are entrepreneurs or who are researchers, and maybe even team up with investors that are sitting here in the room.
Let's get that started. Let's do that right now, shall we? So only about 10 or 12 of you put your hands up to say you were working in the space agency, but space sector, but we've just talked about energy, agriculture, soil, water, many other things. How many are working in one of those sectors? Okay, yeah, more hands in the audience going up. And as Elisabeth has just said, this is a public service with information that is available, freely available out there. So how many of you would like to be partnering with Elisabeth using Copernicus's data now based on what you've just heard? Yeah, great. All of you people need to come and talk with Elisabeth or talk amongst yourselves indeed after this session. Elisabeth, we've got 3 minutes left. How can people stay informed and up to date on what you're doing at Copernicus and the data and information that's available? Because maybe we've piqued their interest here, they want to continue learning.
Yeah, so I'm happy to see so many hands raising now. I invite you to visit our website, copernicus.eu, where you find a wealth of information, also very easy videos to get started, to have a first idea of what it is. And there you have direct access, of course, to the data, but also to our information services, so where you can dive into the needs of your type of business or sector or type of interest. We have also, on top of the thematic services, created so-called thematic hubs that are using information that we get from the different services. We have a specific one on energy, for example, and also on health. I didn't really speak about health yet, but this might be interesting to some people here as well, for coastal regions and for the Arctic as well. Then we are very active on social media, so there I invite you to follow us. And I also invite you to watch out for our next European State of the Climate report. So once a year we issue the Copernicus State of the Climate report that gives us very important information. Like for 2023, you have maybe already seen it was the hottest year worldwide on record. 2022 was the year with really severe droughts in Europe. So watch out for this to stay informed and connect with us.
Elisabeth, thank you so much. It's been a real pleasure having you with us, and also to hear from you and learn about Copernicus, the Earth Observation Unit, but also I think the information that's being gathered, the work that's being done, and that this is part of the public sector, that as people working in sort of all these different environmental sectors, or the health sector, as you say, water, we can access and use this information. It's there as a resource for us. Thank you so much for coming, telling us about it, and sharing with us. And there are some people in the audience that want to speak to you afterwards. Elisabeth, thank you.
Thanks, Dara.
Thanks so much. Now, we heard just earlier from Laurence at the CNES about the space debris issue. And we've just heard about the Copernicus and the constellation of satellites that are being used to help us monitor and protect what we're doing here on Earth. And as such, space debris is a critical risk now for those satellites, and hence for our data and our information. We have now 3 debris experts, maybe I can call them that. They're going to be joining me here on stage to talk about their work. Please welcome, are we ready? Mioara Maria Joldes, who's a researcher and expert in space debris at the CNRS, which is France's National Research Institute. Mioara, come on up. Lefebvre, who is head of product at Aldoria. They're a French new space company. And we have Imogen, who maybe, Imogen, who is the She is the sort of non-space person on our panel. You're from the world of marine science. You're a research fellow and the plastic detective. Welcome to all three of you. I'm just going to turn my chair around slightly so I can see you. Here we go. Now, introduce you a little bit here. So, Mioara, you are at the CNRS. You've created an algorithm, in fact, that is now being widely adopted to accurately predict the risk of collisions. Okay, Leo Lefebvre at Aldoria, you are a French new space company, and you're using data to actually help protect the satellites that are up there at risk from this debris, and therefore protecting human activities in space. And Imogen, plastic detective, from the world of the oceans, you're a National Geographic explorer and sky ocean rescue scholar. And you're going to be actually helping us see this comparison between these two worlds as such, space and our oceans, and how we're moving between them. Let's get started, though, by actually getting a handle on this space debris issue. Space debris being artificial objects greater than 10 centimeters, is that correct? 10 centimeters? Leo, tell us about the size of the problem and how this has changed a little bit over time.
Yeah, so just a few figures first. So satellites in orbit have been multiplied by 5, up to 10,000. And the known objects, which are catalogued by space surveillance companies such as Aldoria, has doubled between 2017 and 2023.
Okay.
So we are talking about objects taller than 10 centimeters. Mm-hmm. But on the other hand, we have a European Space Agency estimating that space debris less than 10 centimeters and greater than 1 millimeter are more than 100 million in orbit.
100 million greater than 1 millimeter?
Yeah.
Okay, wow.
And they are concerned because they are traveling fast. They travel around 7 kilometers per second. So it's as fast as 10 times a bullet. So when a satellite hits this kind of debris, it creates damage which can end the mission.
Okay. So we've effectively seen a large increase in the amount of debris, a large increase in the number of satellites up there, so sort of exponential increase in the risk as such. But also you mentioned the speed at which these things are traveling.
Yeah, and the collision, which was very unlikely a few years back ago, becomes a real problem. And now when we talk with satellite operators, they proceed to collision avoidance maneuvers on a daily basis.
Okay, well, we have Mioara, who's our collision expert. We're going to talk about that in just a second. But that's the perspectives from space. Let's come down and go to Imogen. Can you give us some comparative data for sort of debris or plastic debris and how that's changed over time?
So I'm quite the odd one out in this panel, in that I'm a marine scientist and I specialize in plastic pollution. And I traditionally look at how it's getting into the oceans, the distribution, and also the impact that it can cause. And I wish it was more profound that I got into literally this space, but it was during COVID, and I was watching one of my favorite films, which is WALL-E, which is a great prediction for the future unless we clean up our act. And there's a significant part in the film where all of the humans are having to escape planet Earth because they've made such a mess. And they have to crash through a sea of satellites. And I was thinking, this seems very familiar. Are we doing it up in space as well, in Earth's orbit? I started to go a little bit crazy. If we compare plastic pollution in the ocean with space debris, there are comparisons. So we make over 400 million tons of plastic every year. 14 million tons of that is expected to go into the ocean. And a huge proportion of that is single-use plastic. But plastic was only made about 100 years ago, with the first synthetic plastic being something called Bakelite. And now it's really exploded, that you just have to look around the room and you can see how plastic has revolutionized our life. With the clothes that you're wearing, the seats that you're sat in, the phones that you're holding, even like your lanyards. But then with space debris, how does that compare? So the first satellite that went into space was Sputnik 1 in 1950. And space is a lot more expensive and harder to reach than the ocean, so it's been slower. But there's 10,000 satellites now in space. But we have a rise in mega constellations, such as SpaceX. And SpaceX is planning on inputting 42,000 satellites into space over the next few years. Because of the Kessler syndrome, where satellites in a crowded orbit can collide, this creates hundreds of thousands of fragments. The more fragments that are there, the more likely they are to collide again, creating hundreds of thousands, maybe even trillions of bits. But we've learned so much of the oceans that then we can carry over to space, such as our lack of governments, international cooperation, not looking after a global commons, lack of financing for solutions, both upstream and downstream.
Imogen, I'm going to actually ask about, and we're going to talk about this in just a bit, but I think you've very well managed to set the scene as to why and how the comparisons there are between the ocean plastics and the space debris issue that Leo sort of gave us the context for. I want to come to the subject, though, of the collision risk, which is what we're focused on. Mioara, this is where your work is indeed focused on. You've developed an algorithm, then, to accurately predict the collision risk. So we've got all this debris floating around all of our satellites, the collision risk here. What is the process for doing that? Can you tell us a little bit about it?
Yes.
Oh, does your mic work? Leo, would you like to kindly swap just whilst I'll take that one.
Is it working now? Yes, so good morning, everybody. Thank you all for being here. So I'm kind of labeled like the collision avoidance expert. So I'm just a young expert, let's put it that way, I'm still young. I was working like in the last 10 years already on an algorithm which could actually output a number between 0 and 1. And this number is very important to be reliable because a satellite in orbit, based on exactly whether this number is lower or higher than a threshold, so let's say 1 in 10,000 or 1 in 1,000, depending on this threshold, we will make a maneuver to avoid the debris, or we will not make the maneuver. And of course, this risk has to be kind of assessed based on each satellite operator, each agency. So it was really an important question whether we can reliably assess this number, where we can compute it in a reliable fashion. Mm-hmm. So to get more specific into the science, we currently can have access to the trajectories and the coordinates of space debris and, of course, satellites that are larger than 10 centimeters. That's all we can actually track using radars or telescopes from ground. All the other debris are in themselves a threat, but we cannot monitor them very well. We don't have the accuracy or the precision to see that well in the sky. And based on this kind of more than 30,000 objects that are more than 10 centimeters, they are all catalogued. And their position and velocities are known, but they are not known precisely. In principle, they are only statistically known. So our algorithm takes this statistical information and tries to spit out this number and say, okay, based on this statistical information on the position and velocity, we can say that the probability of collision is less than 0.01%. And then CNES, the French Space Agency, or other agencies can decide whether we make a collision maneuver or not. This is kind of the issue that is in itself currently very difficult to say whether we can reliably assess, or what are the measurements that could actually give us sufficiently good information where we should make maneuvers, collision avoidance maneuvers, or not.
Mm-hmm. And this is where, Leo, you come in. Is your mic working, Leo?
Yeah. I think so.
Fantastic. Okay, I'm going to come to you in just a second, though. So if I've understood correctly, first of all, it's about actually identifying and tracking and collecting all of this data about the debris floating around. And then your algorithm comes in terms of cataloging it and then calculating this probability of the risk, the 0 to 1. Leo, I think this is the way you use this data.
Yeah,
then, right?
what Mioara said is the core of Aldoria's business. We develop telescopes and we observe basically space from Earth. And this issue of the limit of 10 centimeters is at the core of our R&D projects. So we are currently working on telescopes, which by the end of the year will be able to detect objects from 2 centimeters, which will be a huge move forward to have a much bigger view of what's going on out there.
Okay, fantastic. Thank you for adding that in and including how you're working using this data. But why is protecting space important for each of your sectors of work? I'm going to come to you, Imogen, our marine scientist. Why is protecting space important for your work?
I'm still learning how we can use satellites effectively to track plastics. It's quite a new area of research. There's only so much that you can do as one person in the field trying to understand where's all of this plastic going. But satellites, they're basically these huge CCTV cameras in the sky. So I'm currently working on a project with the University of Auckland, and we're looking at sewage discharge in the UK. In the UK, we get a lot of rain, and that means that our sewage systems are overfilling. And that also means that raw sewage is going around the coast, and it's a huge issue. But conveniently, the monitors that the water companies use are also broken or they're not used. So we have no idea that impacts the distribution or how much sewage is going into our coastal waters. But by using satellites and these eyes in the sky, we can have a look at where's it going, how often is it happening, and holding water companies accountable to make change.
So it's very much about not being blinded as such. These satellites are giving you that information. Thank you. Mioara, how about for you and your work in research? Why is protecting space important for you?
Yeah, so I would like to start with a more general perspective. So from the field of research in general and from the CNRS research, protecting a clear space, or also, like we say, a dark and silent space, is very important for many research works in which I'm far from being expert. But the CNRS institution has put up a position paper, stating how important it is for various fields that go from astronomy, from radio astronomy, from stellar physics, from astrophysics, to be able to continue doing research using the space as it is today, and with some more regulations if possible. In the sense that if, for instance, as Imogen mentioned, if SpaceX raises up 42,000 satellites, there was a study in 2022 made from a team using the Vera Rubin telescope that are doing a lot of astronomy measurements, and they work in the visible light spectrum. So if these satellites are up, and they will reflect so much light that in more than 30% of the images they are currently gathering, there will be a trail of light from the satellites. Okay. So most of the images will be compromised. So we are talking now in the visible light spectrum, but we could go in the infrared spectrum, we could go in the radio frequency spectrum, and many, many issues are present, and CNRS has issued quite an interesting proposal for more regulations that could be made up, and especially that could be proposed, especially in the new space law that the EU is supposed to launch very soon, like maybe this month or so. So we are hoping that this will bring more regulations in order to be able to carry on research that is still important in various fields that are broader than mine.
Okay, and I think we're going to touch on the regulation subject in just a short while. So Imogen needs the satellites up there to be able to collect the data for marine science. For space research, it's not just about having the satellites there, but you mentioned clean, dark, silent space as well. So making sure that sort of the data integrity, I guess, and the continuity of that. Thank you for that, Mioara. Leo, why is protecting space important for your sector of work, for our business, communications, military, Earth observation?
Yeah, exactly. As mentioned before in the keynote, our day-to-day life is based on space activities. The whole economy relies on space activities, so telecommunications, positioning, Earth observation, and we see that space access is more and more affordable, so more and more companies are launching more and more satellites. And we see, especially in low orbit, a congestion of the orbits. And we shouldn't take access to space for granted, because once we start the Kessler effect, which has been described previously, there is a possibility, a scenario where those orbits would become completely unavailable. So that's why it's something we should protect, and we should have a responsibility for it.
Thank you. I think this is one of the things I've learned through researching this panel. We think about space as being something that comes out at night when we see the stars. It's there all the time. How many of you are on your phones right now? Yeah, you're using space, okay? It's there all the time, and so protecting it to protect our livelihoods here on Earth is also critical, not just for all the services we're already relying on, but because space is creating new businesses and new business sectors. Aldoria.
Yeah, exactly. The new space is a whole sector, and you can see even another subsector, which is SSA, Space Situational Awareness, which is the sector of the companies trying to map all the debris and to have the full picture I was mentioning before. So all those actors are working for specific services on Earth, but it's become an industry as a whole as well.
Now I want to come back to sort of some of the comparisons, Imogen, that you were making between the oceans and space and the debris, plastics. Well, many of the things we've been talking about here this morning have been about solving the space debris problem and keeping and protecting a clean space. So what are the benefits of that work being done in the realm of space as such for us here on Earth and for your work?
It's all about connecting the environments together. And we were just talking before this panel that many years ago, people said, the ocean is so big, it's not going to matter if we put rubbish and trash in it. We're never going to see the impact. And now you could go to almost any beach and find plastic pollution washing up. And it was Elon Musk that said, don't worry, like, space is so big, we can put as many satellites up there as we want. But now we're starting to see the impact of that as well. I've been told in science often you have to stick in your swim lane. Like, I'm a plastic pollution scientist, stick in your swim lane. Climate scientists over there, space scientists over here. And what we need to do is swim in between the swim lanes and start having this discussion, asking questions, and connecting these environments together, because we'll make faster progress.
Fantastic. Okay, so swim outside of your lanes, people. There's a lot to be learned. Leo, how about for yourself?
You need to think that objects in orbit eventually come back and re-enter the atmosphere, so they burn up for the small part of them. But the biggest one and the most dense ones might not burn up completely and fall on the Earth, which is a risk for human activity. So in Aldoria, we work on this re-entry tracking, so we are able to see if for example, a rocket body or a satellite which is out of service and slowing down is about re-entry, and what is the probability of it to create damage, so that we can have some airspace clearance, maritime space clearance, and protect activities around the place where we have these kind of issues.
Okay. So, Mioara, you mentioned just earlier about sort of the low orbit impacts, and I know that this horrific idea of having a sort of a chain collision here is an issue. But then, Leo, you're saying that could effectively then also bring more debris down here to space, and that's something you're working on. Okay, so Mioara, for yourself, what is it that we're learning from the space research and the work that you're doing that can benefit us here on Earth?
Yeah, so since I started working on this subject, so I have to say that my initial field were more fundamental or applied math or computer science, and it's since I've started working on this problem, I have gained a lot of insight, also theoretical. And I think this is important to maybe for the audience to notice that although we are talking about very practical problems today, the collisions are an issue, and chain catastrophic collision is going to be an even bigger issue. But if you look behind the scene, the actual theoretical tools that we use are really kind of scary mathematics. So if I had told you maybe 10 years ago that I worked on solutions of differential equations with polynomial coefficients, you would say, you maybe would have said, this is pointless, this is useless, who will ever use this? But actually, yeah, this is the core tool that we have used in this algorithm that made it reliable and efficient to be put on board. So I think, for me, this is kind of a way of showing that fundamental research or more theoretical subjects can have a big impact even on this very practical and economical-oriented world that we are living in today.
Okay, thank you so much for that. It's fantastic that we've got a researcher here, someone who's actually working commercial activity in space, and a marine scientist. I'm going to ask you a very quick, sort of like one-word question. The space race used to mean getting to the moon as fast as possible, okay? Elon Musk changed the target a little bit. He's going to Mars. I want to ask each of you, what does the space race mean for you? What are you shooting for? Imogen.
Education.
Ooh. Good one. Okay, so education and maybe swimming outside of those lanes, as you said, crossing education across and learning across the fields. Leo?
I would say the full picture, so being able to track a millimeter debris in the sky.
Okay, so tracking everything, being sure that we can eliminate the risk and protect our eyes in the sky up there. And yourself, Mioara?
Oh, so for me, growing up in a post-communist Eastern Europe country, I was watching Star Trek. Like, space is the final frontier, believe me. But I think maybe in my lifetime, I will not be able to see the USS Enterprise, right? But maybe I will be able to see, and I think we are all going to be able to see the computer on Enterprise. I think in the next maybe decade or 20 years, we will have the computing capabilities of actually making big progress regarding algorithms and regarding really having an intelligence we can discuss with. So I think for me personally, this is the major impact that we will see in the next 50 years, let's say.
That's a wonderful thing to be racing towards, and a wonderful note for us to end on. Thank you so much, Mioara. Thank you to Mioara, Leo, and Imogen. Also to Laurence and Elisabeth for earlier, to helping us understand the importance of space, how we are dependent on space in our everyday activities and our lives here on Earth, and how space is critical for helping us mitigate climate change. Also, big thank you to our two dancers from Minuit 12 who joined us earlier. Please do make sure that you follow them on Instagram, and make sure that you catch Laurence, Elisabeth, or any of our panelists here if you want to start working and collaborate with them. Thank you so much for being with us here today and for helping us understand how protecting space is critical for protecting our Earth. Thank you all. Thank you so much. All right.
Hi everyone. We're going to need the 3 first rows on both sides if possible. If you can move back, we need to free up the 3 first rows. Thank you so much. 3 rows on both